This is part 2 of elasticities of demand and supply. And in part 2, I will be going over the total revenue rule and drawing on the problem that I hope you worked on in part 1. Again, I want to remind you that you are still responsible for the content in your text and lecture and other materials, and this is a quick tutorial to help you grasp the concepts. Okay, in the last tutorial, I asked you to solve for the elasticities of each of the ranges along the demand curve. So hopefully you followed the midpoint method, which I described in detail, and this should be your response. Okay, so this presents some interesting information. What we saw when we were working on our elasticity, we started at a price of $6 and we lowered our price to $5, and we were looking at prices in that range. And the elasticity that we got when we did that was 1.6. Okay, so we know that if we went from from $6 to $5, the elasticity along this range is 1.6%. 1.6. Now, note that the elasticity changes as you go from each area, okay, of the curve. We have a change in elasticities. It is not consistent. This is important because this is also telling us information about our product and how we are pricing on the demand curve. So these should have been the numbers that you got when you were doing your calculations for your elasticity. Note that in my calculation I still left the minus sign there. We're only going to be using absolute value for purposes of this chapter. Okay, so what does this tell us? Why do these change? Well, we have something called the total revenue test. And this changing elasticity, so now I have a new table up for you, and it's the elasticity of demand, absolute value. I just copied it over from our other chart. Note that I took away the minus signs. This tells us that along our demand curve, we have different responsiveness to changing prices. The responsiveness of the consumer is going to depend upon where our pricing is. So elasticities tell us what might happen to our revenues. So let me backtrack and ask you, well, what is revenue? Or what are total revenues? Total revenue means sales. It's the top line on your income statement. It is the number of units that you sell, which would be quantity, times the price that you are charging for that unit. So price times quantity gives you your total revenue. So what we're going to do is we're going to calculate the total revenue at each price point along our demand curve. Okay, so we have at point A, we had a price of $9, okay, but at $9, we didn't sell any product, 0. So 9 times 0 is 0 right over here, okay. We lowered our price to $8 and we sold 1 unit, 1 cup of cappuccino. So 8 times 1 gives us total revenue of $8. If we lower our price to $7, okay, then we're going to sell 2 cups of cappuccino. So 7 times 2 gives us $14 of total revenue. If we lower our price to $6, we will sell 3 cups of cappuccino, and our total revenue is going to be 6 times 3 gives us $18. We lowered, and this is what we did in our example, we lowered our price from $6 to $5, and we now sold 4 cups of cappuccino, And our revenue is 5 times 4 gives us $20. Here we are at $5, and we think, wow, if we lower our price more, we're going to sell even more product, more cappuccinos. And it's true, we lower our price to $4 and we sell 5 cappuccinos. But take a look at what happens to our revenue. 4 times 5 gives us $20. That's just the same as the previous one, okay? So something funny happens here. If we lower the price more, thinking, oh, we are going to get more sales, it is true. The quantity of sales increases, but the lower price starts to bring down our total revenue. So 3 times 6 gives us total revenue of 18. And you can see that if we continue to lower the price, yes, we are going to make more sales. But the price, since it's lowered, is not going to offset, or it's going to be offset by the increase in quantity. And so here we have 2 times 7 gives us total revenue of 14. And if we lower the price to $1, we're going to sell 8 cups of coffee. We're going to think we're doing really, really good. But our revenue is going to go down to 8. And of course, if we give this for free, then we're going to sell or give away a lot of cups of coffee, but our total revenue is going to go down to 0. Okay, so we can see that what happens is at a really high price, we sell no coffees. But as we start to lower the price, we're going to sell more. Beyond some point, revenue is going to level off. And then if we keep on selling or reducing our price, revenue is going to drop. Okay. Now, if we take a look at our table again, and let me erase all of this. Okay. Let's take a look and let's see what is happening. As we lower the price, total revenue increases right here between points E and F. Our total revenue is maximized. Okay, we are getting the most money coming in. And then after that, our revenue starts to go down. So we have revenue going up, tabling off, and revenue going down. Okay. So that's what a total revenue curve looks like. Now, let's also look at our elasticities. Well, what's going on with our elasticities here? Well, here we have an elasticity of 17, one of 5, one of 2.6, one of 1.6. So we say that these are very elastic ranges of the demand curve. And what do we mean by that? Well, an elastic number would be any one in which elasticity is, I think it'd be better if I put it down here, where elasticity of demand is greater than 1. Okay, so over here, all of our elasticities are greater than 1. That is the elastic range of our demand curve. Okay, now, at the point where elasticity equals 1, which is right here, okay, we can see that our total revenue is maximized. Now, it does kind of look like at 4 it's maximized too. Remember, we are using arc elasticity, which is a little bit imprecise. When you start using calculus to figure this out, you will see that it is going to be exactly at this point. When elasticity equals 1, our revenue has been maximized. Okay, so that is a rule right there. Let's see, so when elasticity of demand equals 1, our revenue is maximizing. Right up here. As elasticity falls below 1 into this range, we see that our revenue is reducing, and now we are in the inelastic range. So inelastic range is less than 1. So to summarize, elasticity tells us information about our pricing. Where are we pricing on our demand curve? If we are pricing in the elastic range, okay, so you want to remember that over in this green shaded area is our elastic range. All of this area over here, okay, is our elastic range of our demand curve. Okay, that means that if we lower the price in that range, we are going to be increasing our revenue. Okay, we also have information here. All the numbers are greater than 1. Okay, so that means that we will also be as we start to lower our price, we know that our total revenues are going to increase. Okay, and we see that over here on our table. So you want to be able to see this both graphically and on the table. Okay, now we know that somewhere between 4 and 5 units, okay, we are at unit elasticity. Unit elasticity means that we have maximized our revenue, which means that we should probably stop lowering the price, because if we continue to lower the price, we're going to reduce our revenue. And when we start to do that, this area here where the orange is, this is the inelastic range, and it tells us if we keep lowering the price in this range, we are going to start to lose revenue. And so this is important for a business to know, because they need to know, well, where are they pricing on that demand curve? And should they increase prices or should they decrease prices? And what's likely to happen to the sales of their product and to their revenues? So here is the total revenue test. Basically, total revenue is the amount spent on a good and received by its seller. It is the price of the good multiplied by the number of units sold. Total revenue equals price times quantity. This is a formula that you'll need to memorize. Total revenue test is a method of estimating the price elasticity of demand by observing the change in total revenue that results from a price change, all other things equal. We will be using the total revenue test again when we talk about monopolies and monopolistic competition, so it's worth understanding this. If the elasticity of demand is greater than 1, meaning that we are operating in the upper range of the demand curve, if the price drops, total revenue will increase. If the price goes up, total revenue will drop. Conversely, if we are operating in the lower range of the demand curve, the bottom range, we are probably in the inelastic range. And if price drops, total revenue will drop. If price goes up, total revenue will go up. At the point where elasticity equals 1, any price changes will leave total revenue unchanged, and we have maximized our total revenue. So here's a little table to summarize some information about the price elasticity of demand. I hope you find this helpful, and I will see you in our next little tutorial. We will be talking about cross-price elasticities, income elasticities, and supply elasticity.